Hello, everybody. We are on our last note section for the year. Woo, woo, ooh, ooh. Okay, we are going to be looking at circle segments. Okay, and this is actually going to be a short note section. Let's dive in. All right, for circle segments, there are three different equations we can use to solve for the measure of those segments, depending on what type of intersection we have. So our first type of intersection is going to be intersecting chords or secants that occurs inside the circle. If we have this type, you will take the sections of those chords and multiply them together. So for example, here I have segment of AB divided in half, so that's going to be A times B equal to C times D. So nothing too crazy. You just take those portions along the same line and multiply them together. All right, so I'm going to do this a little bit different. We're going to come back to those two types, but let's do an example of this one first. Okay, let's see. I'm feeling blue. We're going to do blue. Example 1, solve for x. Assume all segments that appear to be tangent are tangent. So I have an intersection inside my circle. Turtle. Okay, I'm going to multiply those sections by each other instead of equal together. So I have 24 times x plus 7 equal to 27 times x plus 5. I'll multiply that together, solve for x. So 24, I got to distribute it out. So 24 times x gives me 24x. 24 times 7, I do not know that off the top of my head. It's going to be 168 equal to 27x plus 27 times 5, which is 135. I like to get my x positive, so I'm going to subtract my negative or my 24x over. So minus 24x crosses out. I'm going to subtract my 135 over to isolate that x. So 168 minus 135 gives me 33. 27 minus 24x gives me 3x. 33 divided by 3 gives me my final answer of x equal to 11. Okay. So this type is my favorite type because it's plain and simple. You just multiply your components together. All right, let's look at our other types. If I have intersecting secants that occur outside of the circle, okay, I will set portions of those lines equal together. So that's how it's similar to intersecting inside. However, you take the portion that's outside of the circle, so A and C, and you multiply it by the sections of those lines. So here, for let's just say chord AB, I take A times A plus B, which is equal to C times C plus D. So you're multiplying by that portion that's outside of the circle, and then you're multiplying by adding the components of the line. All right, let's do an example of this. Example 2, find x. Assume all the segments that appear to be tangent are tangent. So I'm going to take my components outside of the circle and multiply it by the whole line components. So for my first half, I'm just going to look at chord XB. So I'm going to take 12 times 12 plus x plus 8. And I'm going to set it equal to my other segment of 15 times 15 plus x minus 1. All right, I'm going to simplify everything that's in my parentheses first before I multiply. So 12 plus 8 gives me 20 plus x equal to 15 minus 1, which is going to be 14 plus x. Now I'm going to distribute. So 12 times 20. Oh, calculator malfunction. 24, or 240. 240 plus 12x is equal to 15 times 14, which is 210 plus 15x. I'm going to subtract my 12x to keep my x positive. Subtract 210, subtract 210. I get 30. So 240 minus 210 is 30, equal to 3x. I divide by 3 to give me x is equal to 10. All right. Let's look at our last type. If I have an intersecting secant and a tangent outside of the circle, I'm going to take the tangent squared and set it equal to my outside portion of my secant, b, and multiply it by the whole portion of that secant added together. So it's a little bit of combo from that last type, except with my tangent, I square it. So let's look at an example. Our last example, example 3. We are wanting to solve for x. So I'm going to take my portion that's outside of my circle, which is 3x squared, equal to my portion that's outside, 9, times 9 plus 16. All right, let's distribute that square. So remember, when I have something squared, it's multiplied by each component within there. So I have to square my 3, which is 9, and my x, so x squared, equal to, let's simplify our parentheses. So 9 plus 16 is 25. All right, 25 times 9 is 225. I'm going to divide by 9. Well, I guess I could have skipped a step there. But 225 divided by 9 is 25. So I have x squared equal to 25. I'm going to take the square root of that square to get x by itself. And my x is equal to 5. All right, so really the major takeaway from this chapter or from this section is be able to identify what type of equation do I use. And refer back to this slide. If it's completely inside the circle, the intersecting chords are inside, I'm just going to multiply the components of those chords or secants. If I have intersecting secants where the intersection occurs outside the circle, you will take that portion multiplied by the addition of all those components of the secant. And finally, if I have an intersecting secant and tangent, I take the tangent squared tangent squared equal to my outside portion of my secant multiplied by the addition of all the components of my secants. All right? That's it, folks. Lots no sections. So enjoy.